Hello everyone, I am Mark Ivan Flores and I am here to share to you my knowledge about solving AC circuits. So I have a sample problem here which consists of two voltage sources and also several components. So in this side we have a voltage source of 3 angle 0 and one component which is 2 angle 0, and also in the other side we have a voltage source of 2 angle 0 and we obtain it from this formula for V1. I will explain it to you how we obtain 12 angle 0 later. And in this side we have several component impedances, which is 6 angle 45, J12 and also J4. And we have a node here which is the node V, and it is connected to the ground of V3. So first, by inspection, we have only a single component here, so it has the same voltage source coming in this component, which is the V1. So V is equal to V1, V is equal to V1, so V is equal to 3 angle 0 equal to V1, where we can find the I1 in this circuit. So to find I1 using Ohm's law, I1 is equal to V over Z, which is the impedance of 2 angle 0. We divide this term 3 angle 0 over 3 over 2 angle 0, and it is equal to 1.5 volts. So thus we can also find the V1 for correction. Thus V1 is simply Ohm's law, I times Z, which is 1.5 angle 0 amperes times 2 angle 0 here, and the value for V1 is 3 angle 0 volts. So next, how I obtained this voltage source 12 angle 0. It is coming from the simplest formula for V1. It is a given formula to find this voltage source. So for V1, we can simply substitute the value for V1. 4 times 3 angle 0 volts is equal to 12 angle 0 volts. So this is the voltage source for this circuit on the other side. So next, we will now apply nodal analysis in this circuit, which we apply KCL at node V2. So here, 12 angle 0 minus V2 all over 6 angle 45 here, and we assume it is entering to node V2. Also, there are currents leaving node V2, so equal to V2 high potential minus the lower potential V3 all over J12, and also here plus high potential V2 minus V3 all over J4, which in this equation. Next, we distribute the denominators in the numerators. So here in the right side, 12 angle 0 all over 6 angle 45 minus V2 all over 6 angle 45 is equal to V2 all over J12 minus V3 all over J12 plus V2 all over J4 minus V3 all over J4. But here, we cancel it. We cancel the V3 because V3 is equal to 0. So these terms are equal to 0. Then next, we can transfer this negative V2 all over 6 angle 45 to the right side. So it will become positive. Then we will factor out V2. So we will copy this term 12 angle 0 over 6 angle 45 is equal to V2 times the quantity. We factor out the V2, 1 over G12 plus 1 over J4 plus 1 over 6 angle 45. So next, we define we divide 12 angle 0 over 6 angle 45. So it is equal to 2 angle negative 45 is equal to the quantity here. We just add the quantity here. So it is equivalent to 0.466 angle negative 75.3612 V2. So by algebra, we will divide both sides by 0.466 angle negative 75.3612. So in this side, we will cancel this and divide 2 angle negative 45 over 0.66 angle negative 75.3612. So by dividing this, we can now obtain the value for V2, which is 4.292 angle 30.3612. So we can now find the value for I in this circuit. To solve for I, it is simply Ohm's law. I is equal to V2. We can use the voltage V2 all over the impedance of J4 in this component. So we will only plug the values. 4.292 angle 30.3612 volts all over J4 ohms. So the value for I now is equal to 1.073 angle negative 59.639 amperes. So it is just a simple sample problem or problem for these AC circuits using nodal analysis. So thank you for watching. I hope that you have learned something about solving AC circuits.